Okay, so I like those. I like using some of those kid videos sometimes just because they end up simplifying what we're talking about even more than we've already simplified it, right? So what we're talking about, a lot of it, it really is as simple as it may seem, right? So try not to make some what we're talking about harder than it really is, right? One thing that he mentioned in there that Johnny also noticed is when he was talking about color, what did he say about color in that video, Johnny?
All minerals have a distinct color.
Yep, he said that all minerals have a distinct color. Is that true? No, not true. What? Who can tell me why that is not true? Who can tell me why that is not true? Blake?
Some colors have close to the same color or exact the same, even though they're different.
Right. So one of the examples was emerald. So not all emeralds are that same color of green, right? It could be a different hue of green. I don't really know of any other emeralds that are that are anything other than green. I'd have to do a little more research on that. But for the most part, so like gold, there are different types of gold. There's rose gold. There's right, quartz. Quartz is one of the best examples because there's a lot of different versions of gold as well, or quartz as well.
An example is diamonds come in like every
and yeah, diamonds,
one type of diamond that was really popular when I was in like really young for adults was like the chocolate diamonds that are brown, which I don't understand. They look ugly to me.
Right.
I personally like black opal, the diamonds, because it looks like a galaxy.
Yep.
And bismuth's pretty cool.
It is.
Rainbow, but then it comes in like a weird fade, but it's like cubes coming out of cubes. And
right.
So cool design.
Yep. So after the video, we're going to continue on with our slideshow here. So I got a few questions for you just to review. We've talked about all of these. These are some fill in the blank questions that you are definitely going to see on Jeopardy. Jeopardy is coming up because we are in lesson 1.2.3. Next week, we'll be doing lesson 1.2.4. And after that, it's going to be just about quiz time. So we will be doing Jeopardy next week. So I can guarantee you these questions will be on there. So fill in the blank. Diamond and graphite are both pure blank, but diamond is significantly harder. So these are statements that come directly out of your book. So whenever I put in fill in the blank questions, these are coming directly out of your book. So get your book out, and I'm going to give you guys a few minutes to find the answers. I'm going to give you guys a few minutes. I'll give you about 1.5 minutes per question. So I'll give you about 5 minutes. So the first one says diamond and graphite are both pure blank, but diamond is significantly harder. Number 2 says blank has a waxy luster. And then number 3 says diamonds have a luster that sparkles, called what? So I'm going to pause the recording here for whoever's watching online.
Not yet.
So get those written down. Make sure you get those full statements written out with the answer. All of those were found within your book. Some of them were like by the pictures, like in the column, right? So all of those came directly out of your book. What page was number 1 on? Who can tell me what page you found number 1 on, Aiden?
I think it was on 28.
Page 29. Page 29. Yep, bottom right.
I found the third one on 30.
Number 2, what page did you find number 2 on? Where did you find number 2, Max? It was on 30?
No.
Talon says to page 29.
And then 3 was 28.
Oh, yeah, that's what I'm doing.
Number 3, yes, was on page 28.
29 and
Oh, really?
yeah. This says.
Yeah, by
You have to know.
No, you don't need to know the page number. You don't need to know the page number. I was just going over that real quick if someone didn't know where it was at.
You have to capitalize the words like advantage.
No.
It's capitalized. Oh, I guess.
No, you don't need it capitalized. Okay. Let's see, it's gonna go. There we go. All right. So moving on. Get my picture out of the way here. Anything behind there? Nope. I can put it there. Okay. So the cleavage of a mineral, so that is the tendency of a mineral to break more easily with smooth surfaces along planes of weak bonding. What would be an example of a weak bond? Who can tell me an example of a weak bond? Johnny?
Talc.
Talc. Yep, talc has a very weak bond because it is not very hard. Who can give me another example of a mineral that has a weak bond? Max? Gypsum. Gypsum. Yep. Gypsum is very. It is not hard. William?
Calcite.
Calcite. Yep.
Well, it has
So.
low density, that's how you can also.
Right, and that's the point I was about to bring up. So something that is very dense, what are its molecules going to look like? Some type of mineral that has a very high density, what are its molecules going to look like? Aiden, you want to come up and draw? Sure. Aiden's going to come up and draw a molecule that is very dense looking.
Yes.
Yep. Draw some molecules,
They're gonna be like
look dense.
close together. They're gonna be like close together.
Very tight. Yep.
Yay.
Good. Yeah, so the molecules are all going to be packed tightly together. That is going to be a dense or heavy, right? Density and weight, are those the same thing?
No.
Density and weight, they are
No.
not. What is the difference between density and weight? Who can tell me the answer to that? We talked about it last year and 2 years ago. So you were in my class last year or 2 years ago or both. You should know this. Ian, what's the difference between density and weight?
Weight, density is like how compact something is. Weight is like the measurement of how like heavy it is. But density is like compact, like a brick. And
Right.
whenever I don't know what mass would be.
So yeah, that's what I was about to say. Let's throw in mass into the equation as well. So we have mass. We have mass versus weight versus density. Mass versus weight versus density. What are, Ian, what you were given a good description there. Let's start with mass and weight. How are mass and weight different, Johnny?
So mass is the amount of like atoms and stuff, and weight is the gravitational force.
Yep. So the only difference there is weight deals with gravity, right? So what I think about is your weight is going to be different here on Earth than your weight on Mars or on the moon, right? Or even just out in space, right? Your weight will be different. Will your mass be different in space or on Earth? No, it'll be exactly the same. Your mass will be the same because weight has to do with gravity. Mass is what makes up something. It's the stuff inside the substance. And that's kind of the same thing with density. Density and mass are very similar in a lot of ways. But density is more referring to those molecules and how many there are that are all packed together, right? So if I had a structure, kind of like in that picture down there, where all the molecules are all spaced out like this, they're all connected. So I have that example. I could make it look like a cube here.
That's a good looking cube.
It is.
Not too bad. And then I have one that looks like this.
That's like talc compared to diamond.
Exactly.
Weight also looks cool.
Purified wood.
It was very hard to draw this second one, but which one, if you try to cut it, which one's going to be easier to cut? Brady?
The weak one by far.
The weak one by far. Which one's the weak one, Talon? First or second? First one, yep. This top one right here is going to be the weaker between the two, which means it's going to be easier to cut it. Johnny, what was your example that you gave?
Talc and diamond.
Yeah, so a good example here would be,
Or anything.
right, anything versus diamond. right? Diamond is going to be your most, is going to be your strongest mineral. It's going to be the most compact, right? Very, very compact, making it very hard. Talc, not as hard, so it makes it easier to break. So the break, that's what we're talking about with the cleavage part, right? So the actual break when we cut something, that refers to the cleavage, right? So it is the property which is related to the atomic arrangement within the mineral, for example, mica, galena, calcite. So when you cut something, sometimes you're going to get a clean, straight cut. Sometimes it'll break, sometimes certain things will break kind of all jagged, right? So it just depends on the type of mineral that you are actually cutting, William.
Well, that is the bigger, the lungs that's connected all the muscles together. It's gonna be easier to-
Exactly. Yep.
What is that picture?
Which one, the right? The one on the right or the one on the left?
It's
Yeah.
the right's the knife. It's one,
Yeah.
I thought it was a knife like.
it's one of those
That's- yep.
disposable
I thought it was like a knife
ones,
slicing
well,
the
not
ham.
disposable
Oh,
ones,
it's
of like the
Swiss Army
cork
knife.
skirts, the
Right.
turbine.
See,
Yep, so-
Now I see
Yeah.
it.
Yeah, the one on the right here.
Now that I stated it, now you can.
Yep, so that is a Swiss Army knife there. You can see the little corkscrew right there. And it is cutting very thinly
Why it was like
a
laser.
type of mineral. So that's what's going on right there.
Yeah, me too.
Yeah.
That is
Like you got a laser.
a
with a
lightsaber.
How do you get a lightsaber from that?
That's a great question.
Vince, all of these really are
Actually,
paying
real
attention.
life lightsaber.
Okay,
Yeah. Accent, yeah.
so here are some of my, you don't have to write this down. You don't have to write this down. This is kind of just extra knowledge right here. So mica has a basal type of cleavage. So that's the type of when you cut it, what it looks like. The calcite has a I'm gonna say this, I'm gonna butcher this really bad. Rhombohedral, there we go, I got it. Rhombohedral cleavage, right? So when you cut it, it's gonna look like a rhombus. And galena has cubic cleavage. So if it's cubic, it's gonna be more boxy when it's cut. And that's kind of what's going on here in this picture. When it's cut, it has different boxes all around. So that is, you don't need to know the types of cuts there. You just need to know what cleavage is. You need to know that it's the actual cut. You don't need to write this part down either. I just want to give you a little bit extra information here. So cleavage is when the mineral breaks into flat surfaces along weak planes versus stronger planes. So right here, this is kind of how certain types of minerals are going to look. So that's when it's cut in just one direction. You're going to be cutting it along those planes. Right here, this is when it's going to be more jagged. What I like to think about for this one is when you're walking on like a cliff, there's going to be certain jagged edges, certain rocks that look like that in certain areas. So when you cut it, you can't just cut it straight down the middle. You might have to cut it in different directions, which in this example is 2 different planes. Right here, you get even more directions. Now we have 3 directions that we have to cut. And then this last one, you're adding another plane, another dimension. That's going to be the 4th dimension. So yeah, lots of different cuts and lots of different ways to cut one of these, any mineral. Yep, and a geologist is the person who studies all of this.
I have a question about the other one.
What was your question on that one, Brady?
Why didn't you go back to it?
Okay.
What's the one? What's the like? Oh, like you see the purple one?
Hmm?
The whole thing?
Like this.
Is that like
That's
is that like
fluorite.
sunlight
It's fluorite.
off? of
Those are
it?
2 different types
So
of
is that like
fluorite right
sunlight
there.
off of it though?
Yeah, that's just its reflection. Some are going to be lighter, some are going to be that darker purple.
Why did they do that? They should be
Okay,
authentic.
so now we get to the actual fracture. So with cleavage, that's going to be the straight cuts. That's going to be the straight cuts. I want you to write this down. So the cleavage, you're cutting it along straight lines. You're cutting it along straight lines. It could be different planes, so you could have different straight cuts. But fractures is when it's going, think about a bone when it breaks, right? It's not going to be linear. the fractures are not going to be linear. They're not going to be parallel. There could be jagged edges in your cut. So right here with this rock, when it broke, what happened? There's a bunch of jagged edges. It's not actually a straight cut. It's not that cleavage cut where it is a straight parallel plane. This is going to be, it's really hard to see on this. It's easier to tell on my computer.
Obsidian would be a good example too.
Yeah, oh, there we go. That's a little bit better. So you're able to see right here in this cut that it kind of divots in right here. It's not a perfect break. Bless you. Yeah, obsidian would be a really good example for this. So the way a mineral breaks when it does not yield along cleavage or partings, a parting surface, it is called a fracture. So fracture, that's pretty much the best way to think about it. I like to think about fractures when I think about bones breaking or wood. And you snap a piece of like a twig, it's not going to be a perfect cut. If you used a, if you actually used some kind of saw, it's going to be a straighter cut. But if you just break it over your knee, or if you just snap it like this, you're going to have a bunch of jagged edges, right? Aries?
I just remembered why I haven't seen my rose quartz in a while.
Why?
Because when I did the construction, instead of moving the rose quartz, he left it there. So now it's just buried under mounds that have trees on them now. So it's just buried, but there's like 5 boulders.
Big old.
Big of rose quartz. And there's like
that's cool.
one of this green thing that's all like jade. Like, no, it's not jade. It's like, but it is cubed like this.
Interesting.
It's like kind of like very like that.
Cool. Kayla?
I was going to do, so the word either, I just noticed the word for I-4 but not the word either all over.
Right. I don't study any of that, but yeah. William?
For some reason, carrots literally most of the time have like a perfect.
Yes, yeah, that's a good example. When you break a carrot is not usually going to have it breaks pretty much along a plane. Same thing if you cut, I'm trying to think of another one.
Not celery, definitely not celery.
Yeah, not celery. If you break a piece of celery, celery usually has a bunch of different flaky parts. Yep. Max, please stop messing around.
Oh, cucumber.
Strawberries are usually just gonna smush. Bananas, yeah, they're good.
Broccoli is your place,
Yep. Carrot would be the best example I could think of though. Okay, so that's a fracture. So we have different, and yes, I want you to get this part written down. We have different types of fractures. Right? We have what's called an even fracture and an uneven fracture. Pretty easy to remember. An even fracture is a fractured surface where the actual surface is going to be pretty flat. So it almost looks like it's cut straight along a plane like the cleavage, but it's not, because it is not cut perfectly straight along a plane. It might look like it, but it's not. Caleb? So an uneven fracture, it's going to be irregular or rough. So that's going to be so like when you snap a tree limb, a lot of times that fracture is not going to be straight. Sometimes it might, right? The carrot example is a really good example, because when you break any kind of carrot, for the most part, it's going to be pretty straight, but that is still a type of fracture because you're not cutting it perfectly straight down a plane. All right, so that's still an example of a fracture, but it would be more of an even fracture than an uneven fracture.
Is that egg?
Is that what?
Egg. The red thing, the red.
So this is, that right there. Yeah, example. It's another way you're going to see example written. Example. One of you left your water bottles in here. Whose water is this?
Yeah.
So Dylan, this will come at a cost. I will talk to you about payments later. Any of you who leave anything in my class and I have to clean up after you, you are going to have to pay for your stuff back. If it is any kind of papers that I find that you leave around that's around your desk, you will also have to pay. What is your payment? It'll be a type of service. You're gonna have to take out the garbage. You're gonna have to clean up. If they're sabotaging, there will be repercussions to multiple people or just the whole class. What?
In the box.
That doesn't matter, that's fine.
You go, I've left over.
Pretty much, don't leave your stuff on your desk. Don't leave your stuff on your desk. I'm tired of cleaning it up. So that's, I'm only talking to a few people here, but most of you do just fine. Brady, there's good questions and bad questions. No, it's a bad question. Okay, density. So here's our last one we're going to talk about. Our very last physical property that we're going to talk about. So yes, you need to get this written down, and I want you, you don't have to write down or draw this exact example, but I want you to have a drawing similar to it. I want you to have a drawing similar to the gas, liquid, and solid example. So what are those smiley faces? What are those smiley faces representing here, Caleb? Molecules, yep. And when the molecules are more spaced out, it's going to be more of a gaseous state, right? These molecules are not connected to each other at all. They're just floating around, right? So that's gonna be less dense. Thinking of the air, you're able to move your hand freely through the air without any kind of resistance, right? So what happens when you try and, let's think about swimming. When you're swimming, right? When you're trying to run through the water, it's not as easy, right? You're trying to run right now. I'm like, this is pretty easy. But you try to run when you're in water, all of a sudden there's more resistance. It's not as easy to run through water. Because it's more dense when you are in a liquid. Please do not talk. Please do not talk. So that is going to be more dense than a gas. But then you get to a solid. If I were to put you in, think of something that's pretty dang solid. Yeah, I like the concrete example. If I were to put you in concrete, it is in a liquid phase. But if I were to put you in that type of liquid, it's going to be a lot more dense because as time goes on, it's going to harden and become more and more solid, right? So what that means is you're not going to be able to run through that or even get out, right? So that is going to be a more dense type of liquid. Yes, Aries.
The problem for me with the concrete would not be getting out. I would just, that's not the main problem. The main problem is how bad concrete is for your skin. Yeah. Like just when you're mixing it with your hands, it gets all dry.
Yeah,
so
you're supposed to wear gloves.
Stuck in it.
I know, I put in a concrete driveway over the summer.
I know, but Clayton does it without gloves. His hands get all flaky.
Yep, I ended up doing it without gloves too.
I didn't use gloves.
Yeah.
It doesn't hurt.
I had a
It's
rash
just
on
like
my hands.
everything's
Yeah.
rash.
So density, when you're talking about anything, but density of minerals in general, density of matter, that is going to be how tightly something is packed together, right? Something that is less dense, its molecules. Let's go, Caleb.
You got hope. Yeah, part of me. Oh, would you like the name?
Yeah, you could do it.
Yeah, you want one?
Not.
Okay.
Talking should do it.
Okay, you can sit right here.
I would go down to the office and grab some big chests.
Yes, please. So density formula next. Density formula is what we have next right here. So I've told you guys about it already. What I want you to write down here is I want you to write down this equation, just how it's written here. This little weird looking P is what's represented by density. How I like to think of it, it's an upside down backwards D is what density is represented by. So that's density. Density equals mass divided by volume. The thing I love about this little pyramid right here is it represents density equals mass divided by volume. So if your eyes aren't up here right now, pause where you're at for a second. So density, which is right here in the pyramid, equals mass divided by volume. This line represents the division sign over volume, right? So what about if we're solving for mass? Mass equals density times volume. So density times volume, they're right next to each other. So we're multiplying them. We're multiplying them because they're right next to each other. Well, what if we're solving for volume? Volume equals mass divided by density, which makes sense, right? Volume is right here. Look at that. Mass divided by our density would equal our volume. So this little chart right here, it's really nice for when you're trying to solve for density, mass, or volume when you're given two different pieces of information. So yeah, go ahead and keep writing that down. This little pyramid is very nice when you're given, it's kind of like the food pyramid. You're gonna see a lot of other little pyramids that are like this for solving for math equations or even science equations. So this is gonna be your first look at it right here.
You want me to see the water on the floor?
Yep. Yep.
Mr. Why is it P? Is it like from another language or something?
Yeah.
It's like M for mass.
Okay. So I'm going to give you easy numbers here. We have a mass of 2 grams. We have a volume of, let's do another easy one. 2 grams. Yeah, we'll just do milliliters. What is our density? What is our density? If we have a mass of 2 grams and a volume of 2 milliliters, what does our density equal according to our equation here, Jacqueline?
1.
It's going to equal 1, right? Because when we have our mass right here, which is 2 divided by 2, that gives us our density.
What's the unit of density?
Yeah.
Density, yeah, that's a good question. So the density units are going to be grams. So your mass per volume, mass per volume. So if you have grams, it's going to be grams per whatever your volume unit is, milliliters, liters, whatever, right? So your density units are always kind of like, I'm trying to think of something else that's similar, kind of like, wait, I can't think of anything off the top of my head, but density is kind of, it's different from other types of things. That's what kind of makes density, because it is a mass per volume type of example. So if I had, let's say, 2 grams is my mass, equals mass, and I have a density of, so yeah, let's just do 3 grams per milliliter. 3 grams per milliliter. So I have a mass of 2 grams and a density of 3 grams per milliliter. What is going to be my volume here, Max? Why don't you stop being so smiley there with Aiden? Aiden, you need to turn around, buddy. Or else I'm gonna have to give a new seating arrangement to the entire class. Who else can tell me here, Johnny?
So it'd be, so you cancel out the 2 grams and it'd be 2 divided by 3.
Yeah.
I'll do that with you.
Yep. You can just give it to me as a fraction. That's fine.
So it would be 2/3.
Yeah.
milliliter.
Yep, 2/3 of a milliliter. 2/3 of a milliliter equals my volume. How did we get that? We just took this bottom equation right here, mass divided by density. So that would be right here. Our volume, mass over density, gives us our volume. All right, and you guys will see a question or two like that on your quiz. Am I going to give you an equation? No, I am not. So you need to memorize either this chart right here or this equation. What I recommend is memorizing this pyramid right here. This pyramid is going to help you be able to solve any density equation, getting your mass, your density, and your volume, and you'll be fine. Question, Aries?
Just so much more about their one on the decimal part would have just been repeating 6 because.
Right, it would have been 0.66666. Yep, or just 0.6 repeating. Any questions here with the density formula?
Actually kind of a bit of a deal.
Yep, for a lot of you, it's review, but depending on your math level, it could be newer. Or if you had me in physical science, those of you who had me with physical science, so Ian, Aries, Bethy, and William, you guys have done this before. Did you end up doing it too? I couldn't remember.
Part of it, she did like.
Right, because I didn't know if we did it at the beginning of the year or the end of the year, so. Because you got here like March that year, right? Was it February? Okay, so I was pretty close.
I remember that, because your first day was the birthday, wasn't it?
No, before.
Okay, so right here, I have some examples for you here. This is how we are going to describe different types of minerals, right? So we have the luster. The luster of this particular mineral is metallic. Its description, how would you describe it to someone? It shines like a polished metal. So when you polish a metal, it's going to be shiny. What is an example of this? Gold. What does it look like? Well, the luster and the description give you a pretty good idea of what it is. I don't know why I can't ever say this.
Adamantine. Adamant.
Sure. That's its luster. It is sparkly. An example of it would be diamond. What does it look like? Well, it's sparkly, right? What color would you say that looks like? What color would you say that looks like if you were describing to someone, Aiden? Tannish?
Like old paper color.
Or like Mr. Doomer's skin color, right? But without all the redness.
Old paper.
Luster, resinous, looks like dried sap or resin. Sphalerite, and it looks like that guy right there. Actually, it kind of looks like a scab. Kind of looks like a dried scab.
It's like, who has a scab back there?
Right? And then the last one looks pretty glassy. Anytime you're going to be talking about quartz, its luster is going to be glassy. It's also called vitreous, looks like glass, quartz. That's what we got there. You don't have to write any of this down. This is just an example for you. So when you're describing talc, it's going to look pearly, right? What I think of is a pearl, like a pearl necklace, right? That has all those pearl circles. Somewhat iridescent. What does iridescent mean, Aiden?
Iridescent is like kind of see-through-ish.
See-through-ish. I like that.
Oh.
What were you going to say, Aries?
For me, iridescent, and I just think of more like not shiny, but there's like the light bounces off, like how a pearl is like glossy, like he just said.
Yep.
How pearl is the light shines off and bends around.
Yeah, glossy is another really good adjective for that. So waxy or greasy as a luster. So the outside kind of looks greasy. I don't know if any of you have seen any kind of rocks that kind of look like they're greasy, even though they're not. I have. It looks like it's coated in wax or grease. That's going to be the nepheline. Looks like that. Silky, dull. Those are a lot of our luster descriptive words. Yes, Brady.
I can try to get a little bit more.
No, because I'm not requiring you to write this down. All right. So this is the picture of the class I took the other day.
My face.
So there are two types of lab partners. This is when we were doing lab. There are two types of lab partners, right? This is when we're working on our lab with your
Oh,
partner.
this is the day I was in here, yes.
Yeah, Johnny is in your spot.
Are you
Johnny's trying to-
going?
Jacqueline got cut off.
No,
Jacqueline got cut off.
I didn't either, Jack.
What am I doing?
Well, Jacqueline was actually here. No. So who can tell me? So I have one more little slide here that's going to describe what the two types of lab
Hey,
partner
Mr.
is.
You like my face in that picture?
Who can tell me the two different types of lab partners? Brady, quiet please.
Probably I would say most of them are the camera are probably trying to pay attention and focus.
I'm not asking about the photo. I'm just saying, what are the two types of lab partners? I just told you, what are the two types of lab partners, Johnny?
The super serious and then basically screwing around.
So that's pretty much exactly what we have. There's one person who's normally carrying all the weight, right? They're doing all the work. And this isn't just for labs, this is for normally group projects in general. There's one person doing all the work, and then there's someone else just watching them carry the load. So
Me and Kat.
I just thought that was pretty funny. I'm not saying this is you guys, this is something I have noticed after working in labs. A lot of the times, I'm that guy. I'm the guy just right here, just watching my partners do all the work. Kidding.
I'm the guy who is the lab partner because the other people won't let me do anything.
It's getting barreled out late.
Okay, so
It's just when we travel.
that means we have, if I can get my picture back up here. So we have just finished our last lesson here. We have finished our last lesson. So what do we do at the end, Johnny? Summary, a 3 to 4 sentence summary. Now, are you copying word for word anything you find out of the book or your notes? No, you're not. That is plagiarism. So in your own words, write a 3 to 4 sentence summary about the lesson. Now, do I want you writing, I think, I believe, or I really liked this about the lesson?
Yes.
No, that's not what I'm looking for. I want facts. I want the facts. All right, so that's it for today's lesson. Once you guys are done with your write-up, your summary, you may quietly get ready for lunch. You may quietly get ready for lunch. Yeah, it sounds like they're doing something fun outside.
Jamming, Mr. Ryan.
Jamming.